Concentration of hydroxyl ion in a certain household ammonium cleaning solution is 0.025. Calculate the concentration of hydrogen ions. By this, you are going to use this formula of hydrogen ions is equals to constant concentration of water over 0.0025, the concentration of the cleaning solution of ammonium, which is 0.025. Okay, we have like concentration of water is equals to 1 times 10 raised to negative 14. Thereby we have 2 known, and we are going to look for one unknown, which is the hydrogen ions. And by this we say hydrogen ions concentration is equals to 1 times 10 raised to negative 14 divided by 0.0025, and the answer you are going to get is 4 times 10 raised to negative 12 molarity. This is the concentration of the hydroxyl ion, hydrogen ions. In a sodium hydroxide solution, hydroxide ion is 2.10 raised to negative 4 molarity, which is the concentration of sodium hydroxide ions. Calculate the pH of the solution. By this, you are going to use the formula pOH is equals to log concentration of hydroxide ion negative log, yeah. So we are saying negative log of 2.9 times 10 raised to negative 4. By this, we are going to say log of this one. By using the calculator, we are going to find 4.82, which is the pH of sodium hydroxide. Okay, by this, we are saying we are going to use again the formula of pOH plus pH is equals to 14. So we do have the pOH, which is 4.82 plus pH, and you're looking for pH, so it's equals to 14. When we shift on this side, it will be change the sign to be a negative 4.82. By this, we find the answer being 10.82. the pH answer. Calculate the half-life of the decomposition of dinitrogen pentoxide. Rate constant is 5.36 times 10 raised to negative 4. Okay, in this question you are going to say the half-life as a this first order equation. So we are going to say 0.693, which is let the half-life of the decomposition of the nitrogen pentoxide. Okay, we have the rate constant is equals to 5.36 times 10 raised to negative 4, and we are going to use the formula of half-life is equals to the ln of 2, which is this one, divided by the rate constant. And by this, we're gonna just place this rate constant over down and say T is equals to 0.693 divided by 5.36 times 10 raised to negative 4. By this, we are going to use the calculator and say 0.693 divided by the rate constant, which is 5.36 times 10 raised to negative 4. And by this, we are going to get like 1.2929 times 10 raised to negative positive 1, 2, 3, 4, just 3. Yeah. So let's do that. answer. Draw the structure of carbon 3, hydrogen 5 and Pr, which is bromine. So by this we are going to say it has 3 carbons, and the 3 carbons is saying we are going to use a formula of 18 to name this structure. So by 3 carbon we say we're going to throw a structure like this, and then this one is not there. Draw the structure of 3 carbon, 5 hydrogen and Pr, which is bromine. By this we are going to use the formula of 18. Yeah, so it has like 3 carbons, so it's going to be written like a double bond because of the 5 hydrogen carbon, and then we say Pr H CH. The structure is going to be like this one. So the name of this thing will be 1 bromo because of this, and then 1 because it's just 1 propane. So we're gonna omit this coefficient of 1 because it's just 1, so we're gonna write just like bromine, bromo, propene, and this is the name of the structure. Magnesium on this side as a okay. The question says like find the identify the X which is on the right hand side. Okay, we must find the number of molar mass, atomic number of protons on this side should be equal to atomic number of proton on the right side, and the molar mass of the upper side should be equal on the other side, on the right side. Okay, so 26 plus 1 is equals to 27. On this side we just have 4, so we're going to subtract 4. 27 minus 4 is 23. So X on this side must have 23. On the lower side of the proton number we have 12 here and we have 1, so it's 13. 13 minus 2 is 11, so it should be 11. So X is equals to X has 11 protons, and the molar mass of that, the isotope of the X is 23. So we're gonna go to the periodic table and find what is this that has a proton of 11, and we find it sodium. So it should be like 23, 11, and the structure is sodium.